Welcome back to our course in college algebra. We are going to continue our discussion concerning the graph of a function and talk about some other things you can do using these graphs. So, in this video I want to discuss finding the domain and the range of a function based on the graph. Now remember, if you go back and look at our very first video in the course, we discussed how a function was a tool for describing relationships between quantities. So we had a set of values called the domain, that was the input to the function. Then we had a rule for taking those inputs and figuring out the output associated with each of those inputs. And that set of output values, that was called the range. So the domain is the set of all possible inputs to the function. The range is the set of all possible outputs to the function. And you'll also remember from our last video about how to read the graph of a function, the graph of a function is the set of all pairs of numbers of the form input, comma, output. So the x-coordinates of the various points on the function's graph represent the input value, and the y-coordinates represent the output value. So right here, this point has coordinates 2, 0, x-coordinate 2, y-coordinate 0. That means if I use 2 as the input to this function, I get 0 out. All right, well, if we've got this picture, we can answer all these questions. F of -3. Remember the quantity in the parentheses there, that's the input to the function. It's prompting us to find the output if we use -3 as the input. On the function's graph, we can see we have the point -3, 1. That means if you use -3 as the input, you get 1 as the output. Remember, I don't need the function's formula if I have the graph. Okay, so -3 comes in, 1 comes out. All values x such that f of x equals 0. Here I'm starting with the output. I've got a target to hit. I want to produce 0 as the output for the function. What input should I use? Well, remember, graph is input-output pairs. You want 0 as your output. That means you're looking for 0 as your y-coordinate. Well, that's -1, 0. It has 0 in the y-coordinate. This is 2, 0. So there's two x values you could use. Okay, two choices. All right, so if you got the input, look for a point on that graph with that x-coordinate. If you got the output, look for points on the graph that have that y-coordinate. Okay? Now this is asking us for the domain of the function. Okay, remember the domain is a set of all possible inputs. Well, this particular graph, this is all there is. If I had put little arrows on the end, that would mean that the graph continues on in that way forever. But this doesn't have the little arrows on the end, it just stops. Okay? So, I'm looking at the x-axis. Okay, remember, on the graph of a function, the x-coordinates represent the input values. So I'm thinking, okay, what's the smallest input I could use? Well, it looks like -3. If I tried to use an input of -4, well, there's no point on the graph with -4 as the x-coordinate. So I can't use -4. The smallest x value I can use is -3. So I'm thinking, okay, -3 is the smallest x value, so my x's are all greater than or equal to -3. What's the biggest x value I can use? Well, it looks like the biggest x value is this one over here, right? And this point looks like it has coordinates 4, 4. My biggest x value is 4. So my input values are between -3 and 4. We'll talk about this in a later video, but for interval notation, which is a good way to describe these sets of numbers, we're talking about -3 to 4. Now the range, okay, the range, well, that's the set of output values. Graphically, the output values are represented by the y coordinates. So we can see on this picture that the smallest y value of any point on the graph is -1. And the biggest y value is 4. So the range is -1 comma 4 in interval notation. Okay, so if you've got the graph of a function, not only is it very easy to take an input and figure out the output and go backwards, you can also look at the picture and determine the domain and the range. To find the domain, look at the possibilities for x-coordinates of the points on the graph. In this picture, smallest x-coordinate is -3, biggest x-coordinate is 4, the domain is -3 to 4. For the range, we're looking at the y-coordinates. Smallest y-coordinate is -1, biggest y-coordinate is 4, the range is -1 to 4. Okay, so once again, very useful tool, these graphs, provided they're drawn accurately, okay?